Hello one and all, and welcome to the Math Magic Show. Let's take a look at several examples of factoring using only positive values. So imagine first I'm just going to motivate why we factor a particular way. So imagine I have instead x plus 2 multiplying x plus 3. So let's FOIL this out so you can understand factoring better. So as a first step, it would be x times x, that would give me x squared. Then I would have x times 3, which would give me 3x. Then I would have 2 times x, which would give me here 2x. And then I would have 2 times 3, which would give me lastly 2 times 3 at the end in that position, 2 times 3. And then I combine like terms, so I have x squared, then I have the 3x and the 2x, which is 5x, and then I have the 2 times 3 at the end, which will give me a plus 6. So think about this for 1 second. This value in the middle of 5, that's really the 2 and the 3 added together. That's important to observe, and the 6 at the end is really the 2 times the 3. In other words, this 2 times that 3 multiplied. So that gives me 6. You want to really keep that in mind. So when we go into the factoring, all of that will be applicable. Okay, let's take a look at the next stage here. So imagine some examples now. I have z squared plus, say, 2z plus 1. So following what we just did in the previous example, what that means in practice is I need two numbers that multiply to 1 and add up to 2. In other words, a number plus another number equals 2, and then the same numbers multiplied together have to equal 1. So that's all premised on the example I've just shown you. So here, if you play around with these, you will see pretty quickly that the only numbers that make this work are 1 and 1, because as you can see, 1 plus 1 is 2, and 1 times 1 is 1. So in other words, the factorization in this particular case would look like the following. I would have z, and then z, and then in those blank spaces, you stick in the red ones. So z plus 1 times z plus 1. Again, based on a simple condition. Let's do another example. I'll gradually increase the difficulty to bigger numbers, that is. So imagine now I have p squared plus 4p plus 3. So I applied the same thinking as in the previous example. Specifically, I need two numbers so that they add up to 4. So a number plus another number equals 4. That's the coefficient on the middle term. And the same two numbers multiplied together have to give me a value of positive 3. So here the answer is still found pretty easily, because the only numbers that make this true are 1 and 3. 1 plus 3 is 4, and then 1 times 3 is 3. Okay, so that means the following. When I factor, I can put these things together as follows. P, and in the blank spaces, I put each of the values. So p plus 1, say, and then p plus 3 also. So p plus 1 times p plus 3 is the factored form of the trinomial. Okay, let's move on. So now I'm going to have y squared plus 15y plus 50. So here the numbers are getting a little bit bigger, but the same principle still applies. Do keep that in mind. So if I just do what I've been doing, that means I need two numbers, so that when you add them, you get 15, the coefficient on the middle term. And the same two numbers multiplied together have to give me 50 positive. So the only ones that I can think of that do that are 10 and 5, so that 10 plus 5 is 15, and then 10 times 5 is 50. So I can factor this expression on the bottom there into the following. Y, you put the y's down first, one time each inside each parentheses, and then plus one of those numbers, and then plus another one of those numbers. It doesn't make any difference whether you write y plus 5 multiplying y plus 10, or y plus 10 multiplying y plus 5. Okay, now let's take a look at what happens when the numbers get a little bit bigger. So imagine I have g squared plus 17g plus 70. It may not be so obvious anymore, and necessarily in every case, especially when the coefficients and the constant there are bigger. So then what you may want to do is simply look at the factors of that number of the 70. The numbers that you multiply to get 70. Okay, different combinations of those. So let's see here. I might say 7 and 10, because 7 times 10 is 70. I might say 35 times 2, because 35 times 2 is 70. Let's see, I might say 14 times 5, because 14 times 5 is 70. So how do you know which pair of numbers is the right one? Well, besides just multiplying to 70, the sum has to be 17, which is the coefficient on g. Only one that has that here, therefore, is this one, because 7 plus 10 is 17. That matches. The 7 and the 10 are the numbers we need. That means that the 35 and the 2 and the 14 and the 5 are no good for that reason. Important to note, because 35 plus 2 is 37, not 17. 14 and 5 is 19, not 17. See? Okay, so then you continue. So basically I know what the numbers are now. So I need two numbers that multiply to 17. Same two numbers, 7 times 10 have to give 70, which means this is 7 plus 10 in that position, for the reason I've shown you. And now when you factor, this becomes simply g plus 7 multiplying g plus 10. And that then would be the factored form of our expression on the bottom. Okay, I hope you've got all of that. I know I'm moving a bit quickly. Let's take a look. I wanted to show you as much as I can. So here, imagine we have a squared plus 33a and then plus 90. Again, when the numbers are bigger like this, it may not be necessarily obvious what to do, so you need a method in place that is reliable and mechanical. So I will proceed as in the previous example. I'm going to take my 90, and I need to look at the factors of that 90, the ways that you get it from multiplying two numbers. So for example, I could have 9 times 10, or I could have 30 times 3. So that's one possibility. 9 times 10 or 30 times 3 will both give you 90. But the other condition has to be so that when you add them, you get the 33. So you probably can tell what they would be, right? But let's see, 9 plus 10, well, that's 19. That's no good. I need the sum to be 33, the coefficient on A. Okay, so that tells you that this is wrong, which means that the other ones, the 30 and the 3, have to be the right values, because 30 plus 3 is 33, which is the coefficient on the middle term. Okay, so let's take a look at the next step. So I'm going to have that 30 plus 3. That gives me the 33 that I need. Perfect. And then the same 30 times 3 will give me the 90 that I need. Alright, so now we can factor this simply as follows. It's going to be a plus 30 multiplying, as an example, a plus 3. And that is the factored form of the expression. Okay, so we have just done, like, I think 6 examples pretty quickly. But once you've done enough of these, I hope you can catch the rhythm and see what's happening here, okay? Well, that is it for me. Thank you so much for watching. Please leave a like and subscribe, and I will see you in another video.